Welcome to the HBI course, Knowledge Engineering with Semantic Web Technologies. This is Lecture 1, Knowledge Engineering and the Web of Data. And today, in the last section of this lecture, we would want to talk about the Web of Data and how to make use of it. So let's have a closer look at the Web of Data, how it represents itself today. So today, the Web of Data is a huge cloud of data sources that are linked together in the sense of linked data that are publicly available in most senses. So it's called linked open data. And these are publicly available data sets on the web identified via URI and accessible via the standard web protocol HTTP. And the nice thing about these data sets is they do not stand for themselves separated. They are linked to data in other data sets, and therefore it's called linked data. And it forms this huge called linked open data cloud within the center. So the node in the center is the DBpedia that we have already heard of in the last sections of the lecture, because it's a general encyclopedia, and in a general encyclopedia there is some kind of reference information about lots of most entities that exist here in the world and in the web, and therefore other data sources and data sets, of course, can use DBpedia as kind of a reference and link to DBpedia. Therefore, it's kind of a hub in this linked open data cloud. And in the Web of Data, according to the last count of this cloud, and this was in March 2014, there are represented about 81 billion facts encoded in RDF with lots of links, 800 million links between these facts. So we will talk about this linked data and deal with linked data later on in the course of these lectures. I will give you one prominent example of websites who makes use of linked data resources. One prominent example, for example, is the website of the BBC. And the BBC Music program was one of the first using linked data resources and publicly available open data resources on their websites. Simply because if you want to provide a website that reflects your current program, and your current program, of course, is constantly changing. In the radio, one song is played after the other. Maybe you want to give some additional information about the song that is currently playing and about the artist who sings or performs the song. And of course, the information about this artist is changing constantly. He or she is giving concerts, he or she is releasing new albums, new songs and stuff like that. And of course, the biography of the artist is changing. And to maintain a website like this in a manual way, so for each possible artist and for each possible song and album that has been published, this of course is a huge effort and rather costly and expensive. So therefore, people at the BBC thought, okay, we can make use of publicly available data and we can access this via really simple access methods like they are provided for linked data in the Semantic Web. And of course, they make use of information that is available in the DBpedia, and there are specialized databases like, for example, Music Brains or Discogs that provide special information about music and about artists. And what the BBC Music does is, of course, it tries to collect and to reference information about artists and about works that are performed in the current radio program or also on the TV program, and they gather this information dynamically on their website. So what you see on the website for a song, for an artist at the BBC is information that has been gathered from live sources, like for example the biography information is taken from Wikipedia, and other things like, for example, the latest albums that have been released by the artist. They come from Discogs or from Music Brains. So this is quite nice. So what makes the website of the BBC Music so special? So simply, information is dynamically aggregated from external publicly available data. So it's Wikipedia, Music Brains, and Discogs. And this data is available without having to do something like screen scraping, for example. So usually if you want to access external data or an external website, you can use a specialized proprietary API, application programming interface, that the website is offering. And if the website does not offer an API where you can access directly the data, you have to do something like screen scraping. It means you read the entire web page and you have to do some intelligent parsing to get the data out of the natural language text. And screen scraping is something tedious because if you change something on that website, the screen scraper and the parser of the screen scraper possibly will not work. So you must constantly adopt your screen scraper to all the changes that take place in the websites that you try to harvest. So with linked data, it's really perfect because you have a very simple general API that is based on general simple web technology. You use simple an HTTP request to the web server without using a special port or something like that. So you don't have to consider how to get beyond a firewall or something like that. And then you transfer it with HTTP, the data, in a format called RDF that we have already heard about. And the nice thing then is you create the website on the fly and your data is always up to date with all manual interaction. So that's great. So, and of course, it's rather efficient because you save a lot of money. Okay, but what else can you do with semantic information on the web? So the most important thing on the web today is to look for information, to retrieve information, and you do this, of course, with a search engine. In a search engine, we have learned this already. Sometimes the queries that you have are ambiguous, and because of this ambiguity, there is the problem that in the retrieval you will have lots of noise because the search engine not really knows what you mean by your query. And on the other hand, maybe search queries work in the way that, for example, only the string that you type in your query or in your search window, this has to be in the document you retrieve then exactly in the same way. So metaphor synonyms are not considered. So we have talked about that information retrieval with natural language always is cumbersome in some way. So what could a search engine that really understands your question do? Okay, let's have a look at this. So, for example, we have the search query Jaguar of 2000. Of course, for us it's not quite clear if the cat, the car, or the operating system is meant. So also, if a search engine has lots of semantic available knowledge, it does not really know what the query string of the user means. So either way, it has to present, for example, options that the user can choose from. And you can get these options in an ordered way, so clustered, for example, that you take all search results together that belong to the cat or to the car or to the operating system. So you have to do some refinement. So now let's suppose we refine this to the car and we want to have information about the car. Then the search engine has also to consider what does the rest of the search term mean. So of 2000, what does this mean? For a car, it can be some kind of a technical parameter. But it can also be some parameter like the construction year. So to get hold of that, you can use statistics, and of course you need the knowledge representation for the cars that you are looking for with the name Jaguar, for example, and to make some consideration what belongs together to generate in the end the answer. So for example, you might think of a construction year. So you see here, although if sufficient semantic information is available, this process, document retrieval, stays complicated and difficult. So there are general problems. For example, you have to interpret the query string of the user correctly without boring the user, of course. If you always ask, did you mean that or did you mean this? This, of course, then has problems with the usability and the user gets bored or the user does not like to use the search engine. The thing is that the search engine will not be able to read the mind and to get the intention of the user because the user context, what the user thinks and what the user has done previously, is missing. So this is also kind of a personalization problem. If you keep track of what the user is doing, you might get an idea of what he will look for if you have an ambiguous query. So you simply have to take into account what the user has done in the past, and then you have to make an assumption of a probability. What could he mean in the future? So the correct interpretation of the query string is difficult. Then also, of course, the correct identification of all the entities that are referred to in the web pages, and to do this automatic disambiguation process. So here is lots of things to do also in the future, although if we have some semantic information already available in the web. But it works. Search engines know more about search results and HTML pages and result pages than you might think. Maybe you know this section of Google. It's the commercial section when you want to do shopping with Google. And there you can look for, of course, a query string. So we had here this example, Jaguar. And what you get there is, of course, you get a result of the best fitting search results, and you can filter them in a really intelligent way because, for example, here you can filter it for the price. So what the search engine does here is it can, or it is able to extract the price correctly from the web page. But this is only possible because the web page is endorsed with some, in quotations, semantic information. In this sense, it's schema.org and it's only structured information, but also structured information is some kind of a semantic information. So Google and other search engines, for example, they use schema.org. We will talk about it later on also. And with schema.org, you are able to provide additional information about your content of your web pages, like, for example, the price or also the category, what your product fits in. And then the search engine can read this, and you can use this for intelligent filtering, for example. So there is already some semantic out there. But there are more difficult problems. Let's take a look at this problem. You all for sure will know the big or the Great Wall of China. But the problem is, so how long is this Great Wall of China? If you ask Google, how long is the Great Wall of China? What you will get back is not a simple fact, the length of the Great Wall, but it will be a list of documents that contain maybe the answer. But there, the user has to take an additional step. He has to read the document to get the answer. So it's more sophisticated, or would be more interesting really to get the answer at once. There are already search engines that are able to answer questions like this. One example of them is Wolfram Alpha. Maybe you have heard of Wolfram Alpha. And here you can ask questions, and if you are lucky and the knowledge that is required to solve this question is already present in Wolfram Alpha, and the question is not too difficult, of course, then you will get the perfect result. For example, here we have asked how long is the Great Wall of China, and we see here in the results section it is 21,196 kilometers long. And if you want to read it in miles, then you have also a unit conversion and see that it's longer than 13,000 miles. So this is quite interesting. And this, of course, is not the end of the line. So a few years ago, maybe you have heard here of the Jeopardy champion Watson, this IBM software that was able to beat the human Jeopardy champions in this quiz game. And we are talking here about a renaissance of the so-called soft artificial intelligence, because here techniques from soft artificial intelligence together with semantic technologies, together with traditional information retrieval, together with machine learning, knowledge mining, and lots of statistics, were able to solve a rather complex task to answer questions for this special quiz game. And right now, Watson has been developed further, and there are new areas or new domains where this software also can be applied on. So question answering and fact retrieval is one of the application areas of these semantic technologies and knowledge engineering, so the subject of our lecture. Another thing that is also related to the search process, to the answering of questions, is the so-called knowledge exploration. That is also able to we are also able to perform this on the basis of semantic information that is out there in the web. So we have already seen that the semantic information is expressed in kind of statements which are written or encoded in RDF. And this means we have entities that have properties or are connected to other entities, and of course also the relations somehow are described between these properties in a semantic way. And if you have entities and relation between entities, this might form a giant graph of connected, linked entities, and you can navigate this graph, of course. So you can get from one fact to another interesting fact. So for example, if you start here at the blue entity DBpedia Neil Armstrong, who was the first man on the moon, you will get the information from DBpedia that Armstrong was on the mission Apollo 11. And then you might get also the interesting information about the other crew members of Apollo 11, which were Michael Collins and Buzz Aldrin. And Apollo 11, of course, was part of the Apollo program. And if you are looking closer at the Apollo program, maybe you will find another Apollo mission, which was Apollo 13, which has become rather famous because of the movie that they made about it. There was some accident or incident. You might remember this phrase, Houston, we have a problem. This was from Apollo 13. And then you get to the class space accidents and incidents. And from this, maybe you will also get to the Space Shuttle Challenger catastrophe, so which was also an accident or incident several years ago. So what you see here is, with the help of this kind of knowledge graph, you will be able to browse and to explore the knowledge that is available on the web. And by doing this, you might end up with some interesting information that you were not aware that you were really looking for in the first place. So this might be some kind of, let's say, lucky finding. So this is called serendipity, in fact. So knowledge exploration is also one of the interesting things we can do with the help of semantic technologies. So now you might wonder, how is it like, or how will it be like to surf this semantic web? So if we surf the web today, we follow a simple model. So we have a retrieval service, so the search engine, which, for example, looks for web pages that contain information according to our information needs. And then we retrieve these documents presented by the search engine, by the retrieval service, with the help of a so-called presentation service, which is then a browser. So with the browser, we access the result pages that are presented to us by the search engine. So it's always the same cycle then here to get access and to surf the web. In the semantic web, this process is a little bit different. So we have here the user, of course, and the user will have something like a personal assistant. And this personal assistant supervises an infrastructure of intelligent services. And these intelligent services, they surf the web and they retrieve information from the web according to the user's needs. And the personal assistant of the user coordinates this gathered information in some kind of a, let's say, private, adaptive, virtual web page that the user can access. So we see this already in some preliminary stages today, but in the future, this will be the everyday way to surf the web, that we have a personal assistant somewhere on a local computer or also on somewhere in the cloud. And this personal assistant gathers data, collects information according to our personalized information needs, and it will adapt, it will learn together with the user and according to his preferences. So therefore, in general, we distinguish between 3 different generations of web documents. So in the first generation, shortly after the web came into existence, we simply had HTML pages, and these pages were static, and to get the information how these HTML pages should be formatted and presented to the user in the browser, we had this cascading style sheet information that were giving formatting information. So this was static. So we simply retrieved the HTML and CSS from a web server, and that's it. Today we are in the second generation of web pages. There we have lots of interactive web pages and dynamic web pages. Dynamic web pages, of course, they are template-based, so we have some kind of a content management system which is connected to a database, and there on the fly a dynamic web page is created according to the current information need of the user, so he accesses some information, and it's not a static page, but it's put together with the help of a content management system from a template and from information that is accessed by a database. On the other hand, we also have intelligent web pages in the sense that we have some interactivity programmed into the web page. You all know JavaScript or Java applets, which means you can put programming code into the web page and to make some intelligent actions or perform some actions on the web page itself interactively together with the user. So these are the interactive web pages. And in the future, like we have seen on the last slide, we will have some kind of virtual web pages and adaptive web pages. It means these web pages, these virtual web pages don't really exist on the web. They will be put together by our personal assistants, which will be netbots or something like that, that are based on information extraction and presentation planning, which again is influenced by the preferences of the user. And then these netbots, they gather the information. These are these intelligent infrastructure services, and they put it together on a virtual web page for a specific user. And of course, these web pages might be adaptive, so there is a user model in the background, and the machine who manages the user model supervises all the actions of the user, and according to the user preferences, it decides and makes adaptations to the information needs that are represented or presented on the web page. Yeah, to achieve all this, you will need lots of technologies, and here is a short summary of the toolbox of semantic web technologies in the web that are available and that we will talk about in the course of the lecture. So there are several W3C standardized languages for knowledge representation in the web. So URIs, we already have talked about URIs, then XML, XML schema, RDF schema, OWL, the web ontology language, and the rule interchange format, for example, for knowledge representation with standardized languages. Then we have to put this knowledge in existing web pages. So we use HTTP protocol, we use RDFA or Gridle, and we use schema.org and lots of other technologies and encoding standards we will talk about. And in general, knowledge engineering in the semantic web requires contributions from various fields of computer science. First of all, of course, we have to talk about artificial intelligence. And here we are talking about soft artificial intelligence, which means things like machine learning, for example, or optimization technologies, natural language processing technologies, which also refer to linguistics. We will need to talk about cryptography, about databases, about theoretical computer science, because you always have to look at the complexity of the technology you are using and whether some solutions are feasible or not. And of course, we have to talk about computer architecture, software engineering methodologies, systems theory, and also about computer networks and computer networking. Okay, we have reached the end of the first lecture. This was the 7th part of the first lecture. And in the next lecture, we want to talk about semantic web technologies and about the basics of semantic web technologies.